Another problem session. So today we're doing, as in this week, we're doing JEE Advanced 2025. 2025. Oh, 2025. And this paper 2. And this is question number 5. Good. So this question is pretty interesting. It's pretty conceptual, and you can actually do a lot of it, very little calculation. Okay, so you have some point charge Q, and there is this is a sphere. The Q originally is at 20 centimeter. A sphere diameter is so a sphere of radius. So this is 10 centimeter, and this also 10 centimeters. Let's draw to scale. So same distance. So this also 10 centimeter. The total distance is 20 centimeter. So we can just use the letter R for this, and so this is equal to 2R. Okay. The sphere then grounded. So this first configuration, so this is before, so part A is before grounding. What is, so this situation A for part A. Part B is we are going to ground the sphere. So this is the center. This is where the charge is. This is the Q. And we're going to ground the sphere. So this is supposed to be plus charge. Then some plus charge will go to the ground. And it's about how much charge is going to flow into the ground. Then part C is what happens after this. So I go from this to that, and then the grounding is cut. So no more grounding. And Q is still there. So how much charge remains over here? And part D is about final electricity potential. So it's the same situation like this. It says removed point is moved by a distance for the center of sphere along the red. So actually, I misspoke here. The charge is moved further out. So the distance from here to here is now 3R. Is the grounding is then removed from the, okay, and it's the same figure, so I don't have to draw it. Okay, let's do them out. Some numbers given. Q is is 10 to the minus 8, and this value is in SI units. All right, so what do you need to know to do this problem? Okay, first you need to know is from a point charge at a distance r, some distance r, at this point P, it's a point charge Q, so potential at point P has to be K Q over R, reference at R equal to infinity, potential at infinity is 0. So this formula goes with that reference. Okay. So let's see, before the grounding, what will happen? Let's look at that. Before the grounding, so there was, before I brought this sphere, there was some potential over there. When I put the sphere, now the sphere gets, this side is charged and this side is equally distributed. So potential there will be the potential of this guy, these charges, the equal and opposite induced charges. So at this location, this point, say point O, there will be, let's call it minus sigma plus sigma. So these guys, because they're equal and equal distance, each one of them will give you this kind of thing, and they will cancel out. So the way A will work out is, so you need this information and you need a superposition principle. So V at P will be wave V from some charge, as many charges I got. So here we have a whole bunch of charges on the sphere, this side and on this side. And so for A, we have V at O equals to V of Q plus V of plus sigmas plus V of minus sigma, and these will, by symmetry, this will be added to 0, so just V of the Q, which is a 2r distance away. So using this formula, excuse me. So using this formula, I'm going to get K 2r, and let's calculate it. So K is 9 times 10 to the power 9. Q is 10 to the power 9, or 10 to the power 8 actually, in Coulomb. And this is 0.2 in the meters. So this guy will kill all but one. So you have a 90.2 is 2 times 10, basically 5. So 450 volt. So when we look at it, it says, yep, this sphere will be, and sphere is the same, whatever the potential here is the same potential. So third thing we should write down, which we are going to use, is a conductor is an equipotential body. Is this the same thing means electric field inside in conductor is equal to 0. And if you remember, electric potential is minus del V. If this is 0, the V is constant all around. Okay, that's what it means. So figuring it out one point gives you everything. Now, if you didn't figure out over, suppose you wanted to do somewhere here, then these guys will not cancel. These guys will not cancel. And so this is still with the same value, but it will be different from plus sigma and minus sigma. By picking a point in the center, we use the symmetry to make this claim that these will add up to 0 only at that point. Okay, so A is good, was very nice. How about B? Now charge is going to flow. So this is because now I'm going to ground it. So instead of 450 volt, this is now 0 volt. So whatever charge is here, because it is sphere, we can think of the charge to be placed over here. So let's see, you have a potential of this guy, which can be thought to be potential. This guy is placing everybody else, and potential of a charges here. So plus charge will go away, but there are minus charges, and we can assume that there's a some q prime. I'm going to put its potential, and its potential must add up to 0, right? So you from here already know this guy's potential is 450 volt. So this guy is producing 450 volt on this. So let's work it out here, right here on the right side over here. So A and sigma minus, let's do some. So 0 volt is equal to what's produced by charge A plus what produced by the sigma minus. This one we already know this is 450 volt. This one, the way we're going to calculate is we are going to think of this as I place all the sigma minus charges over here as a q prime, and this will be a distance r. So it's going to be k q prime over r, and of course r is 0.1 meter. Okay, let's work it out. So q prime should equal to 450 minus 450 r over k minus 450 times 0.1, 9 times 10 to the power 9. So this 0 is eaten up by that, and this becomes 5. So it's going to be minus 5 times 10 to the power minus 9 coulomb. Let's see if that's what they have, charge flowing. So what's left over here is the one that's its cousin fluid over here, its pair flow down here, those sigma plus over here. So it should be from the sphere to ground is okay. So this was correct. This is correct. That much charge. So this is the charge that stays. So its partner floats. So this stayed, and what happened to the pen? On a sphere that originally a sphere was neutral. Originally a sphere was neutral. That means plus 5 times 10 to the minus 9 coulomb flowed into the ground. And that's correct too. After grounding removed, so when I removed this, like this place here, when I remove this, that charge, it should be something is not, so that minus 5 times 10 to the power minus 9 coulombs should stay over here. So it's just the same calculation, already done the calculation. So that's also correct. But what is the potential over here now? Well, Q is way out there. So let's work out what the potential will be. So we have a Q here, and these Qs are minus 5 times 10 to the power minus 9 coulomb, and this is 1 times 10 to the minus 9 coulomb. This is R. This whole I've put too far away, too small a sphere, but this thing is 3R, and let's work it out. I mean, some of the algebra already done, but we can do it again. This is the Q, and this is minus Q over 2. You can see it's 10 to the minus 8 coulomb. So 10 times 10 to the minus 9, and it's 5 times, so just use the same symbol. So from here, you're going to have same thing, so you're going to have a Q, KQ over 3R plus K minus Q over 2 over R. So KQ over 2R, that this one we already calculated, so 2 over 3 minus 1, and this is 450 calculation earlier, minus 1/3, so minus 150 volt. Let's see, that should be the voltage of the sphere. This is incorrect. It should be this should be 100 minus 150 volt. Okay, so that's what it is. This is a good problem. It kind of involves several concepts: point charge, superposition principle, and a conductor being equipotential. And we used it a little creatively to come up with a solution. Okay, take care. Bye.